Okay, another projectile motion problem. We'll tackle it from scratch and I'll try and talk you through it again. This time, switching things up, we've got a volleyball. I'm not so good at drawing volleyballs. They got those panels kind of like that. That's as good as my volleyball is going to get. It's hit horizontally at 18 meters per second, but this time it's hit from a height of 2.2. So there's our ground. This distance is 2.2. And again, it follows a nice parabola. Crashes into the ground somewhere over here. We're asked for where does it land. So although it may look different than the last one we did together, the ball that was thrown, physics-wise, this is the exact same question. Our numbers fit in the same slots, our unknown is in the same place. So we sketched it, we labeled our numbers, we identified the unknown. Now we're going to start the component that doesn't have the question mark. So since I don't know where it lands, which is a horizontal thing, we're going to start with the vertical. We're considering this one motion, this one ball flying through the air from both perspectives, horizontal and vertical. Vertically, it falls 2.2 meters. Gravity pulls it down at a rate of 9.8 meters per second squared. And the one that we sometimes forget is that first split second it's airborne, it's not falling yet. So it's got a V1 of 0, and we're curious about time. Like the last one, like a lot of our projectile problems, I don't care about the V2. So like a lot of these problems, I'm always going to use this equation, the 1/2 AT squared equation. Since that V1 was 0, this whole first term disappears. So really what I've got is 2.2 equals 1/2 of 9.8 times t squared. That means 2.2 is 4.9 t squared. I'll let you do the math on that. Flip the 4.9 to the other side. You're going to get 2.2 over roughly 5, so that's going to be like 0.4. Then we got to do the square root of that. Ends up being, we're going to be between 0.6 and 0.7. On your calculator, you can double check, but we're going to get, I got 0.67 seconds. We now know how many seconds it's airborne for. Now, if we change perspective again, if you were way above this, watching this volleyball fly through the air, from the perspective of above it, you may lose track of the fact that it's falling and just see it cruising across the ground at 18 meters per second. And it does that for 0.67 seconds. So horizontally, we only have one equation for the horizontal, just d equals v times t. In this case, we're solving for the d, so I'm going to write it that way. The volleyball, it says it was hit at 18. The first part, we figured out it's in the air for 0.67. 0.67 is pretty close to 2/3. 2/3 of 18 is 12. If you do the math with your calculator, we'll get 12.06 meters within rounding. So this volleyball is going to land 12.06 meters away.